Hello and welcome to this webcast, Bringing Category 6A into the Enterprise. The webcast is being delivered by Lindsay Kuhlman, Product Manager for NetKey Copper and Fiber Cabling Systems with Panduit. Panduit also is sponsoring the seminar. We thank them for making the event possible and for providing its technical content, and we thank you, the members of our audience, for joining us today. During the seminar, Lindsay Kuhlman will explain why applications like high-speed Wi-Fi, along with power delivery through PoE, have made enterprises appropriate environments for the capabilities of Category 6A cabling systems. She'll describe why in places like office buildings, classrooms, healthcare facilities, user requirements are meriting strong consideration for Category 6A. At the bottom of your screen, you should see a red icon. You can use that to submit questions throughout the seminar. We'll have some time for Q&A with Lindsay at the end of the seminar. For those of you who plan to obtain an attendance certificate today, I'll walk you through the process of obtaining that certificate before we begin our Q&A session. If you have any technical difficulties during the broadcast, please first click the gold Help icon at the bottom of your screen. That will open a window that answers some common technical questions. If the information there doesn't solve your problem, then go back to that red icon, submit a question through Q&A, and a member of our support team will work with you to correct your problem. So thank you very much for putting up with my housekeeping there today. And without further ado, it gives me pleasure to introduce today's speaker, Lindsay Kuhlman. Lindsay, whenever you're ready.
Thank you, Patrick. Good afternoon, everyone, and thank you again for joining today's webcast on Category 6A in the Enterprise. As Patrick mentioned, my name is Lindsay Kuhlman, and I am the Product Manager for Panduit's NetKey Copper and Fiber Cabling Systems. In today's webcast, we'll start by looking at the macro trends that are affecting the way we build our networks. More specifically, we'll examine the technology trends happening in schools, healthcare, and the retail and office spaces to get a better feel for what our networks will have to support in the coming years. We'll then take a deeper dive into some of the applications that call for 10G-based-T and review the unique characteristics of Category 6A cabling. One of the most frequent questions we get from customers at Panduit is, should I stick with Category 6 cabling for my new enterprise installation, or should I make the jump to Category 6A? To answer this question, we really have to look at 10 gigabit Ethernet, and more specifically 10G-based-T, which is 10 gigabit Ethernet over copper twisted pair cabling. Category 6A cabling is required to fully support 10G-based-T Ethernet. What you see here is a forecast presented by Intel for 10G-based-T Ethernet port shipments over the next 5 years. The red line at the top represents the percentage of 10G-based-T ports being deployed in the data center, and the green line at the bottom represents the percentage of 10G-based-T ports being deployed in the enterprise. 10G-based-T was initially adopted for data center applications. However, that space is moving beyond 10 gig and onto 25, 40, and even 100 gig, which is why we see such a decline in data center over the next several years. The reason that we are having this discussion today is made pretty evident by the dramatic uptick in the percentage of 10G-based-T ports being used in enterprise applications. We can attribute this growth to technologies like wireless, digital imaging and video streaming, as well as industries like trading, finance, and healthcare that are bandwidth intensive and rely on speed of data transfer. The decision on whether or not to deploy Category 6A in the enterprise often comes down to budget restrictions. But the good news on that front is that the cost to deploy 10G-based-T has reached the point where it is significantly cheaper per gigabit than its 1 gig predecessor, 1000-based-T. In fact, 1000-based-T is now 4.5 times the cost per gigabit than 10G-based-T. When we look at the comparative per gigabit cost to deploy of 1 gig versus 10 gig cabling, and take into account all of the current and future bandwidth-thirsty applications that are flooding the enterprise space, the question of if you should install Category 6A cabling really comes down to when you should install Category 6A cabling. As I mentioned, the decision to go with Category 6A is often a financial decision. The best way to think about it is that you can spend slightly less on Category 6 cabling today and pay for Category 6A infrastructure in the near future, or you can spend slightly more today and only have to install cabling infrastructure once for the next 10 to 15 years. Panduit recommends Category 6A for all new enterprise installations to address applications which we will discuss further, such as wireless and the growing presence of wearables and mobile devices, power over Ethernet, and the ever-increasing demand for bandwidth that current and future technologies will demand. At a really macro level, what is driving the need for increased bandwidth in the enterprise? The answer, the Internet of Things. I'm sure most of you have heard this term tossed around over the last several years, but it has only recently started to trickle into our lives. I use the term trickle here because the Internet of Things is not something that is blatantly obvious to all of us, but over time it is affecting how we interact with technology, and in turn, how we must design the infrastructure to support all the new devices and capabilities that continue to be launched. The term Internet of Things was actually coined in 1999 by British entrepreneur Kevin Ashton, so it's been around for quite some time. At the highest level, the Internet of Things can be defined as the amalgamation of all network devices that feed data to us and to one another, with the ultimate goal of improving efficiency and accuracy in our daily lives. Cisco released this infographic, of which I'm only showing a small piece, to give us a better idea as to how the Internet of Things, or as they call it, the Internet of Everything, is going to affect our lives over the next 5 years. You'll see that back in 2008, we reached a global tipping point where the number of things connected to the Internet actually surpassed the number of people on Earth. Since then, the number of connected devices continues to grow significantly, and by the year 2020, we expect there to be over 50 billion connected devices on Earth. Let's take a look at how the really vague term of Internet of Things is driving the need for Category 6A cabling in some specific enterprise verticals. We'll start with education, where schools are deploying one laptop per child and the traditional lecture is no longer par for the course. Then we'll take a look at healthcare, and finally, we'll cover some of the more consumer-based technologies that put demand on our networks in the office and while we're out. Are our small offices and retail stores prepared to handle multiple wearables and mobile devices per person, along with the usual bandwidth consumption caused by daily business? The Telecommunication Industry Association has published 2 standards that are very relevant to our conversation this afternoon. TIA 4966, which is the telecommunications standard for educational facilities, and TIA 1179, the standard for healthcare facility telecommunications infrastructure, both recommend Category 6A copper cabling for new installations in these verticals. We'll now take a look at some of the trends in education that are driving bandwidth consumption. Gone are the days of dusty chalkboards in the classroom. In recent years, they have been replaced by laptops or tablets for each student, and educators are using technology to collect data about how students learn to improve and customize the classroom experience. All of this is providing a more interactive and personalized learning experience. However, it is straining wireless networks and forcing a lot of data through cabling that was not designed to support each person in the building using bandwidth-intensive applications at the same time. In a society where attention spans are pretty limited and teachers have to cram as much curriculum into the day as possible, time is one of the most important things that we as cabling professionals can give back to educators. By installing Category 6A cabling, we provide a larger highway on which all of that data can flow, delivering content faster and ensuring that lag time to load a video isn't holding up an entire class of 7-year-olds. At the most basic level, the flood of technology into the classroom has resulted in a massive amount of data that didn't previously exist. Educators are now collecting data on assignment completion time and rate, learner and group patterns like how they click through content, saving personalized courses for hundreds of students in each school, conducting feedback analysis, like where are students spending the most time and what do they find most difficult. And at the end of the day, they can actually compile a comprehensive ROI report for their curriculum, which is a very powerful tool for the educator. In addition to the flood of big data from the education space, teachers are now looking for ways to turn learning into a fun, hands-on experience. We're calling this gamification. Why? According to Talent LMS, learners remember 90% of what they learn by doing or through simulation, compared to just 10% of what they read and 20% of what they hear. While gamification of education is not quite mainstream today, I expect that it will pick up considerably as schools begin to update their technology infrastructure. Gamification requires a robust network to support 30 students per classroom, all interacting with an online, feature and graphics-rich curriculum at the same time over the wireless network. Again, it comes down to lag time. If students are constantly waiting for content to load, the experience of the simulation becomes frustrating rather than educational. With Category 6A cabling, we enable more of that data to flow at the same time. Another trend that is becoming popular among educators is personalization. When we say personalization in this case, it can come down to adjusting learning pace, approach, or even the way the content is presented. What this means for technology is, again, a large amount of data that must be stored and retrieved for each individual learner. Perhaps the most demanding trend in education is the shift to mobile learning. Talent LMS expects mobile learning to become the dominant medium for education material because it gives students easy access to the material, can provide contextual learning through the use of QR codes, GPS, and even augmented reality, and it delivers content in a way that is more digestible. The reliance on a small screen to deliver the same curriculum means that educators must be succinct in their delivery. What does that mean for a school network? Likely a higher dependence on wireless. In TSB 162A, as referenced by that TIA standard 4966, the cabling standard for educational facilities, TIA provides guidelines for wireless access point density based on building type and expected occupancy. Typically, we expect one access point per classroom, or for about 25 people at the K-12 level. However, as your room increases in size and the expected occupancy increases, it is important to ensure you have the appropriate access point density to provide wireless coverage for all occupants. As we will discuss, Panduit recommends pulling at least 2 Category 6A cables to each access point for any new installation to account for data, power, failover, and the addition of any new access points in the future. It is easier to pull 2 cables during initial construction rather than have to go back and add an additional run after the fact should you need to increase your access point density. The last trend in education that we will discuss is automation, which requires substantial bandwidth and storage and goes back to my initial point about big data. When we talk automation in education, it really means automated content creation. Educators can quickly build quizzes and tests using online content or customized content to each user's skill level based on past performance. As you can see, technology in our schools has moved far beyond the days of the old AV cart and dry erase board. While 1 gig cabling might have been sufficient in the past, the reliance on a fast network to deliver interactive, personalized content via the wireless network really begs for 10 gig infrastructure to accommodate the flow of data in a timely manner. As with education, the healthcare industry has really been revolutionized over the past decade or so by the availability of real-time information and imaging. I won't spend too much time covering healthcare topics, especially in an advanced hospital setting, because I think that the understanding for 10 gig cabling is pretty well established at this point. Today's medical advanced imaging equipment requires vast amounts of bandwidth to provide concise, real-time images. In smaller clinics and doctors' offices, however, the need for 10 gig cabling has likely not been seen up to this point. With the move to electronic medical records and telemedicine, fast and reliable network infrastructure has become crucial to servicing patients both in the office and remotely. New technology like wearable sensors to provide real-time data such as vitals and the ability to connect home health care direct to a remote doctor relies heavily on the ability to provide a constant data and a reliable video connection. With health monitoring, the actual storage of data isn't so much of an issue because we can easily collect the same data just a few seconds later. However, the flow of information and fast retrieval is critical. I do want to point out that healthcare equipment provides a unique challenge for copper cabling, and that is electromagnetic and radio frequency interference. EMI and RFI pose a substantial threat to transfer of data over copper cabling. To address this, your cabling must be designed to protect against external noise to prevent excessive signal degradation. Shielded cabling can be very expensive and requires additional grounding and bonding that is not required for unshielded or UTP cabling. Panduit's unshielded Category 6A cabling is designed with a unique feature called matrix technology. The matrix design features a discontinuous metallic shield that provides protection against external noise and essentially functions as a shielded solution without the additional grounding and bonding requirements. Matrix technology is included on all of our Category 6A components, including jacks and patch cords, and in our advanced matrix cable to ensure that your cabling infrastructure is protected against noise from end to end, making it the perfect solution for healthcare needs. The last enterprise cabling application that I would like to discuss is the retail and office space. I recognize these are two fairly different installations. However, the reasons for moving to Category 6A cabling in both retail and the office are very similar. For this discussion, we look back to the idea of the Internet of Things. Building automation and intelligence is quickly becoming mainstream. Our lighting, window shades, HVAC systems, locks, security systems and cameras, and any number of other building systems are now networked and can be controlled wirelessly via sensors. This is a lot of demand on our network infrastructure, both wireless and wired, that has not existed in the past. As more pieces of our buildings become intelligent, the strain on our cabling will only increase. The last thing that we want to happen is to have our air conditioning or lighting be the reason for a network bottleneck. Many of these products can also be powered using PoE, which is Power over Ethernet. As we will discuss further, the latest PoE++ standard performs best using Category 6A cabling to provide heat dissipation at higher wattages. In addition to all of the networked building automation systems that are now transferring data over copper cabling and wireless, we must take into account the multiple wearable and mobile devices that each of us uses on a daily basis. Gone are the days where we only had to worry about bandwidth consumption from one desktop computer per workstation and possibly one cell phone per employee or customer. Our office and retail networks must now be designed to account for things such as fitness tracking devices like a Fitbit, smartwatches, smart glasses, as well as multiple mobile devices per person, which likely includes at least one laptop and cell phone per person, with the potential to add in a tablet or additional cell phones. In addition to consumer mobile devices and wearables, retail companies are now moving towards mobile point-of-sale systems. All of these devices are relying on wireless access and must be taken into consideration when planning access point density. Unique to retail applications, marketers are getting creative with the way that they merchandise product in the store. As with the rest of our lives, in-store displays and signage have gone digital and are now networked to allow for quick updates on anything from simple sign verbiage to a new pricing rollout. On a large scale, retail and commercial spaces are turning to digital signage to attract our attention and communicate with us. At the core of digital signage applications, we find the intersection of network cabling and audiovisual technology, with new innovations such as HDBase-T, which is a new cabling standard for copper twisted pair cabling specifically designed for audio-video applications. I will go more in depth on HDBase-T later in the webcast, but to put it simply, this technology turns a pretty advanced AV installation into a simple structured cabling application. Category 6A cabling is recommended by the standard to support HDBase-T at its fullest capabilities. Do note that HDBase-T operates on a separate network than traditional IT. All of the technologies and applications that we've reviewed thus far rely on one thing: a robust wireless and wired network to support the increase in bandwidth consumption and meet our expectations on the time to deliver content and data. I've spent the first half of the webcast giving a pretty high-level view of how technology is changing and has the potential to have a major impact on our network infrastructure in the enterprise in the coming years. The second half of the webcast will be focused on the technical aspects of wireless deployment, PoE usage, and HDBase-T technology that will all bring us back to the need for Category 6A copper cabling in the enterprise. We'll start with wireless deployment. Access to a fast, reliable wireless connection is at the core of many of the applications we have discussed. What we are looking at here is a roadmap from IEEE for wireless access points spanning from 2012 into 2017. This chart is pretty busy, so please forgive me. I'll try to simplify it as much as possible. Starting at the left side of the screen, you can see that we're looking across time at 3 different ranges of wireless access points. Our focus for this discussion will really be the top 2 tiers. As we look back over the past 3 years, it is pretty evident that 1 gig Ethernet really has not been relevant for new wireless access points since 2012. As we look at this year, 2015, and beyond, pay close attention to the bottom row, which calls out the Ethernet speed necessary to support the bandwidth at the access point. We have clearly moved beyond 1 gig and into 2.5 and even 5 gigs, which are being studied as we speak to evaluate the capabilities of obtaining these speeds using existing Category 5E and Category 6 cabling. Beginning in 2017, the bandwidth required for the high-end access points reaches beyond 5 gigs, and we will have to use Category 6A cabling to achieve the required Wi-Fi speeds at the access point. My main point here is that the wireless speeds are increasing much faster than Ethernet speeds, so installing anything less than Category 6A cabling to your access point is likely to result in obsolete cabling infrastructure in the next 3 to 5 years. Next comes my favorite part of the whole webcast because I get to speak in robot. The other thing that I want to draw your attention to on this graphic is the notation on the arrows of Wave 1 and Wave 2. This is in reference to the transition from Wave 1 of 802.11ac to Wave 2. Wave 2 Wi-Fi moves us from single user, multiple input, multiple output, or SUMIMO, to multiple user, multiple input, multiple output, or MUMIMO. MUMIMO brings us a huge improvement to wireless network throughput and will greatly ease the strain on dense wireless networks. With SUMIMO, data rates increased with new technologies and standards updates. However, those increases were only felt by one user at a time. With MUMIMO and 802.11ac, access points can simultaneously send one or more data streams to multiple users at the same time, providing a huge positive impact to the overall network and ultimately delivering 3 times the amount of data compared to SUMIMO. At this point, MUMIMO only works from downlink connections, which means from the access point to your devices. These devices still have to contend with one another for transmitting data back to the access point. However, this latest update truly improves our wireless capabilities and allows one wireless access point to serve many more devices than ever before. As I previously mentioned, TIA has developed TSB 162A to provide guidance for cabling wireless access points. They recommend pre-cabling using square grids, but please ensure your cells are no larger than 60 feet by 60 feet. For dense environments, they recommend a smaller cell size or adding an additional access point to the cell. TIA also suggests that you run Category 6A cabling to each access point with a maximum link length of 80 meters. You may remember from our wireless access point roadmap a few slides back that 2.5 gigs and 5 gigs were listed across the bottom line as Ethernet speed requirements to support the access point bandwidth demands. I mentioned that the industry is conducting feasibility studies for utilizing existing Category 5E and Category 6 cabling to support these higher speeds without having to run new cabling. IEEE has developed a study group for NGEABT, which stands for Next Generation Ethernet Access-Based T. Quite the mouthful. Again, the goal of this study group is to evaluate the possibility of achieving higher bandwidth over existing cabling. It is believed that legacy Category 5E and Category 6 cabling can support up to 2.5 gigs, and that legacy Category 6 cabling can support up to 5 gigs. The target for the new 2.5 and 5 gig standard is the end of 2016. I really want to stress that these new standards should only be considered for brownfield applications, where you are simply upgrading your access points. For any new greenfield installations, it is strongly recommended that you install Category 6A to support the ever-increasing Wi-Fi demands. Like I said before, Wi-Fi speeds are increasing much faster than Ethernet speeds, so it is vital to have the cabling infrastructure in place to support any upgrades that you may need to do. Panduit recommends pulling 2 Category 6A cables to each access point to support data, power over Ethernet, provide for failure, and ensure you have cabling in place should you need to add an additional access point. Moving from wireless deployment to PoE, let's look at some of the applications for PoE and why it is beneficial to use Category 6A cabling to power your devices. Here I have listed some of the more common applications for PoE, or power over Ethernet. Some of the devices that you can power using copper twisted pair cabling are point-of-sale readers, IP cameras, wireless access points of course, video conferencing equipment, some of the building management systems and lighting, and thin clients. As PoE technologies advance, we will be able to add more and more applications to this list. Pay close attention to the power requirements of these devices over on the right side of the screen. All of them are more than 30 watts. Let's take a look at the PoE standards and capabilities. As you can see, the first PoE standard, 802.3AF, was ratified in 2003 and provides only 15 watts of power. At present, we have PoE Plus with 802.3AT, which was ratified in 2009 and provides 30 watts of power. As of next year, we will have a new PoE standard, PoE++, which encompasses Type 3 and Type 4, providing up to 90 watts of power over twisted pair cabling. This really opens the door for a lot more of our world to be powered using Ethernet, but there are a few things for us to consider when deploying PoE. The main concern when deploying power over Ethernet is the temperature rise in your cable bundles. In order to avoid signal degradation and actual physical damage to the cable, the temperature rise in the center of the bundle can be no more than 15 degrees Celsius, as recommended by TIA. Let's take a look at some testing that Panduit has done on temperature rise in cable bundles to demonstrate why it is important to use Category 6A cabling for PoE. What we are looking at here is temperature rise in a 100 cable bundle for the 3 types of PoE by copper cabling category and wire gauge. The horizontal black line in the center of the chart marks off that 15-degree temperature rise mark that we cannot cross when deploying PoE. Starting on the left side of the chart, you'll see that for plain old PoE, which delivers 15 watts, remember, you can safely use any of the copper cable types that we have listed below, whether it is Category 6 or Category 6A, 28 gauge, 26 gauge, or 23 gauge. Moving to the center of the chart, we start to run into some heat dissipation issues with PoE+, which is our current standard. If you would like to use 28 gauge cable, whether it is Category 6 or Category 6A, you must limit your bundle size to less than 100 cables. To support PoE++ Type 4, which will give us that 90 watts of power, we really only have one option to keep the temperature rise within an acceptable range, and that is Category 6A 23 gauge cable. As we increase the power capabilities of PoE, it is important to keep this in mind. To achieve the highest possible power output without degrading your signal, Category 6A is the best cabling option. There are some ways to mitigate heat rise with bundle sizing, which I will go over next. What we're looking at here is some PoE cable bundle guidelines for PoE and PoE+ on the left and PoE++ on the right. As you see, if you want to use Category 6 or Category 6A 28 gauge cabling, you have to limit your bundle size to 48 cables for PoE or PoE+, and actually 24 cables for PoE++. If you would like to do 100 cable bundle, Category 6A 26 gauge cable, Category 5E 24 gauge cable, Category 6 23 gauge cable, and Category 6A 23 gauge cable will all support 100 cable bundles for PoE and PoE+. When we move to PoE++, those numbers start to drop pretty drastically, and you will see, like I showed in the previous slide, that the Category 6A 23 gauge cable is the only thing that you can use to do a full 100 cable bundle. With PoE, there is some concern with connectivity, and you have arcing when the plug is removed. This does not occur when the plug is inserted, but it is a concern. What you're looking at here on the left is a picture of a plug and jack fully engaged, and you'll see the green circle is the jack, or the contact point between the plug and the jack. And the red circle is where that arc occurs when we disengage the plug from the jack. Panduit's plugs and jacks are designed so that we don't get the damage to the actual contact point when you disengage that plug. The carbon buildup may prevent data transmission on other products. Finally, let's talk about HDBase-T, which is that AV standard that I discussed previously. So Category 6A is recommended for HDBase-T, but what is it? HDBase-T is a connectivity standard that delivers audio-video, Ethernet, control, USB, and power over a single twisted pair cable. This is really meant to replace all of those analog signals and even HDMI that we have used for years for AV and just put it over a single twisted pair cable. Let's look at some applications for HDBase-T. The first application that we're looking at here is more of a school application. And again, this does not run over a traditional IT network. There are specific HDBase-T switches. What you're looking at here is you're running a category cable from the HDBase-T switch direct to the HDBase-T projector in several different classrooms, much like a zone architecture. Another way to deploy HDBase-T, which is more of a digital signage application, is what we're looking at here. You're running your category cable from your HDBase-T switch to your first display, and from there you're daisy chaining up to 800 meters with category cable. Again, Category 6A is recommended for HDBase-T applications. You can use Category 6 or Category 5E, depending on your length and what you're trying to accomplish with the technology. Finally, let's talk a little bit about what makes Category 6A special over Category 5E and Category 6. Category 6A is susceptible to something called alien crosstalk, and this is really noise from external cables affecting the signal on a Category 6A cable. It is not specified for Category 5E or Category 6. So let's look at this chart. Category 5E, Class D, maximum bandwidth is 100 megahertz. Category 6, 250 megahertz of bandwidth, but you have to worry about crosstalk and return loss. Then for Category 6A, we go up to 500 megahertz, but we really have to worry about that alien crosstalk. And when I mentioned Panduit's Category 6A cabling having matrix technology, that is our alien crosstalk suppression. It's vital that this is there so that you are not losing your entire signal when transmitting over Category 6A. Equipment cannot compensate for alien crosstalk. So let's recap. The Internet of Things is driving the need for more bandwidth everywhere we look. Schools, hospitals, and doctors' offices, stores, and the workplace are some examples that we've discussed today. To support all of these applications, networks require robust cabling infrastructure to support more bandwidth-intensive applications, wireless deployment, PoE++, and these new AV technologies like HDBase-T that we've discussed. So from here, I'm going to throw it back to Patrick, and we will take some questions in just a minute.
Lindsay, thanks very much for that information. We will indeed get to questions in just a moment. I know that some members of our audience have an interest in obtaining an attendance certificate today. So before we send a few questions Lindsay's way, I'll let her catch her breath a little bit and discuss the attendance certificate. At the bottom of your screen, a number of icons there. Some of you have used the red icon to submit questions. There is an icon of a slightly different color, something that's a rose or purple type color. That icon is called certification. If you take a look at that icon, click on it and open it up, it will alert you when your certificate is available for download, and it should be available to you shortly. You do have to spend a certain amount of time here with us today in order to qualify for that certificate. So if you just keep your eye on that purple icon, when your certificate is available for downloading, it will present itself in that icon. Moment, I am give you a slide as well. So just before we get into questions with Lindsay, the email address on this slide, webcastmaterial@penwell.com, is where to go if you do not get an attendance certificate today. That webcast material email account is managed by a group that will be able to ensure your attendance today, verify it, and issue you a certificate. I'll come back to this slide again before we wrap up at the very end to put that email address in front of you one more time. But for now, there it is, webcastmaterial@penwell.com, should you not be able to obtain a certificate today. Also want to remind members of our audience that this presentation will be available on demand for 6 months. So today, mid-July, it will be available for 6 months from today, which I believe, if I can still count correctly, bring us into the middle of January 2016. So anytime over the course of the next 6 months, should you wish to come back and revisit this, this will be available in its entirety for on-demand viewing for the next 6 months. with that, I want to bring Lindsay back in if she's on the line with us still.
I'm still here.
Thank you. Thanks. A number of questions from members of the audience, and if I could, I would like to send some of them your way. So the first one to send to you says, I am in the process of installing wireless access points using Panduit Category 6A. At the site is a distribution warehouse that is being built in the Midwest. Asks, why is there a shield around the UTP cable, and does that shield need to be grounded? So asking specifically about a Panduit product and about the use of it. Why is there a shield around the UTP cable, and does the shield need to be grounded?
Sure, thank you, Patrick. So Thomas, our Category 6A cabling actually has what we call matrix technology, which I mentioned briefly in the webinar, and it looks very much like a traditional shield. However, it has some cuts in it which make it discontinuous, and it doesn't require the grounding and bonding that a traditional shielded solution would have. Hopefully that answers your question.
Thanks. So it does not require the grounding and bonding, like you said, that's typically found with a shielded cable. Is that right?
Correct.
Got it. Thank you. Another question to come your way asks, will Category 6 cabling support 10G, Category 6 as opposed to 6A?
Okay, thank you. Category 6 will support 10 gig in some cases, but it's really going to depend on some external factors like distance limitations and noise and things like that. So yes and no is the answer to that question. To be safe, I would stick with Category 6A.
Thanks, Lindsay. Next one for you asks if there are concerns. Are there concerns when using a 24 gauge, 24 American wire gauge permanent channel between the patch panels, so permanent link of 24 AWG, and then patch cords that are 28 gauge in orientation or in construction? Sure.
The only issue you have here is a slightly shorter channel length due to some attenuation on the 28 gauge patch cords. The 28 gauge patch cords actually have a 1.9 derating factor, but you're really only losing about 4 meters to your channel. So 96 meters is your max channel length instead of 100 meters.
Thank you, Lindsay. More keep piling in for you. Next one concerns HDBase-T. Asks, how common are HDBase-T devices and are manufacturers making AV products with HDBase-T interfaces in large amounts? In other words, is there kind of critical mass of these products in the marketplace at this point?
This is my favorite question. So HDBase-T at this point, it kind of functions as an HDMI signal extender right now. So there are plenty of HDMI signal extenders out there on the market. And what this looks like is you'll have an HDMI cord into one end of the extender, and then you'll run twisted pair cabling between the first extender and the second, and then HDMI cable out to your display, whatever it may be. There are some projectors out there that have the HDBase-T chip in them today. There are not laptops that I'm aware of at this point, or TVs, for example. The chip is still very large, so as they decrease the size and improve the technology, we expect to see a lot more HDBase-T enabled devices out there.
Thanks, Lindsay.
There
Next
are plenty
one.
Of,
Go right
sorry.
ahead, Lindsay.
I was just going to say there are plenty of HDBase-T switching matrices out there, though, if you're going to do a digital signage application.
Thank you very much. Sorry to have interrupted you.
Oh, no problem.
Next question asks about bundles. You mentioned 100 cable bundle sizes, but can you have bundles side by side or bundles on top of each other?
Yes, and I just pushed a slide to you guys to show. You can see if you want to break up, for example, a 96 cable bundle, you can break that up into 4 24 cable bundles to reduce that heat in the center. That is an option.
Perfect. Another one for you. The entire topic today was Category 6A, and this asks, is Category 6A the same as this Category 7 cable that I have heard about?
It is not, actually. Category 7 is always going to be a shielded cable, And to be honest, there's really no standard for Category 7 at this point, and I don't think there ever will be. So we're kind of jumping straight from Category 6A into Category 8, which is definitely going to be a data center application. And the connectivity is slightly different as well. So you can use Category 6A connectivity with Category 7 cable, but you'll be limited, obviously, by the capabilities of that connectivity. There are some specialty connectors for Category 7, but they're not widely adopted by the industry, and there are no standards for them at this point.
Terrific. Thanks very much, Lindsay. I think that that does answer several of the questions that we did receive. Want to, if I'm able to, want to bring our audience members back to a slide with an email address on it, and there it is, webcastmaterial@penwell.com. That is the address to email if you do not obtain an attendance certificate today. Again, the way that you receive the attendance certificate is to access the icon near the bottom of your screen. That is a purple type color, some shade of purple. The certificate should be available within that icon called certification. And I believe that that will just about do it for us. So on behalf of Cabling Installation and Maintenance and its parent, Penwell Corporation, I offer sincere thanks to Panduit and to Lindsay Kuhlman for today's presentation. Of course, we thank you, members of our audience, for joining us today. We very much appreciate your attendance and the ability to provide you this information today. So thanks to all of you. We wish you all a good day. Thank you again.